For our next example of writing equations of lines, we're going to be given an actual slope and then we're going to be given a point. Now in this particular instance, our point is not going to be the y-intercept. It's going to be some random point that's on the line. And the first way that you'll be able to tell that is that it's not 0 and some number which would represent the y-intercept. So you can see in example number 2, the point that was given to us was 2, 3. And then it had a slope of -1/2. Now, if you refer back to the concept summary box at the top of the notes, you can see that we're given a form of a line called the point slope form. Now this form of line is given to us specifically for this type of example. So you can see here in my example that we have a y and a x that are in black type and they have no subscript. And the reason that I have it like that is because it's to remind you that you need the y and the x in the final equation. Then I give you a y1 and an x1 with the subscripts. We've put it in different colors here, and that is specifically to show you that that is the specific place where you're going to enter the information from the point. And so we can say that this 2 is our x1 and this 3 is our y1, and that is specifically what's going to be inputted into those two parts. And then last but not least, we have the m, which is in green in this particular instance, and that is our slope, and so we can directly replace our slope with that. Now, once you've done the basic substitution here, we've put in the 3, we've put in the 2, and then we've put in the -1/2, we're not completely finished. This needs to be simplified, which basically means we need to get y by itself, and we need to get it in slope-intercept form, and so we'll have to do a little work here. And so if we go down a little bit, we'll see the final part of this being simplified. And so we're going to take the -1/2 first, and we're going to distribute it, and then we're going to add 3 to both sides, and that gets us our final answer in slope-intercept form. So using that example and the point slope form from the concept summary, go ahead and work sample problem number 2 for us. Okay, so hopefully you've had a chance to do that. It gives us two parts here. It tells us that we have an equation that passes through 1, 2, and I immediately recognize that as not being the y-intercept. And then it tells me I have a slope of 2. Now keep in mind that the slope is the same thing as m, and so that's m equals to 2. So I'm going to take my point slope form. I'm just going to rewrite it here so I can plug directly into it. Remember, one of the y's and one of the x's has to stay through to the final equation. So we're going to only input our information into the y1 and x1, and so I have y minus the y1, which in this case is 2, equals slope, which is also 2, times x minus x1, which is the 1. So I'm going to start this by distributing the 2. So I have 2x minus 2. And then finally, I'm going to add 2 to both sides, leaving me -2 plus 2. Now the reason I wrote this extra step in here is because I want you to pay attention to what happens here. The -2 and the +2 actually cancel each other out, leaving us 2x plus 0. And so what that is that's a y-intercept that is at the origin. And so this is still in slope-intercept form, so it's been simplified all the way. However, we don't tend to write 0 in our equation, so our final answer simplified all the way will simply be y equals to 2x. Okay, and that's an example of using point slope form to write the equation of a line.